I was up late last night rereading Frank Herbert's Dune, specifically the parts about lichens. The planetologist with that obsessive dream of turning a completely dead planet into this lush green paradise.
Oh, right, the ultimate sci-fi terraforming dream, changing an entire ecosystem from scratch.
Exactly. But then I picked up this stack of research from the Chinese Academy of Sciences, and I realized that lichens really isn't fiction anymore. This is actually happening right now in the Tengger and Taklamakan deserts.
It is. Though they aren't using giant sandworms to move the Earth, they're actually going in the exact opposite direction. Microscopic.
Yeah, the papers call it soil seed. And honestly, for our deep dive today, the mission is to look at how scientists are effectively condensing a century of natural geological history into just over a year.
It's wild to think about.
It really is. But before we get to the seed, we have to talk about the soil itself. Because, I always thought sand was just sand.
That's a super common misconception. If you want to turn a desert green, you can't just go out and plant trees. The sand moves way too much. You have to stabilize the surface first. You need biocrusts.
The living skin.
Yes, that is the best way to describe it. It's this biological carpet made up of cyanobacteria and lichens and mosses and fungi.
Wow.
And when these tiny organisms get wet, they secrete these sticky sugars that literally glue the sand particles together.
So it stops the wind from just stripping the land bare.
Exactly. It reduces wind erosion by up to 80% and traps water. Without that skin, nothing else can grow. But the problem is that in nature, building that skin takes decades, sometimes even 100 years.
And we just don't have 100 years.
Yeah.
I saw in the source notes that early lab attempts to speed this up were pretty messy. They tried spraying liquid bacteria, right?
They did, because logic dictates if you want things to grow in a desert, you add water. But practically speaking, it was a logistical disaster. Imagine trying to drive heavy water tankers over shifting sand dunes.
Without any roads.
Right. You'd spend more energy just getting the truck out there than you would fixing the sand. Plus, the wind would just sandblast the wet bacteria away before they could even establish themselves.
Which brings us to the breakthrough. The team at the Shapotou Desert Research Station completely flipped the script. They stopped trying to transport the water.
Yes. They focused entirely on the biology instead. They took strains of cyanobacteria like microcoleus and mixed them with organic matter and fine particles into a thick paste. The researchers actually compare the process to mixing cement.
Mixing cement with living things. That sounds incredibly permanent.
It really does. They mold this paste into solid blocks or pellets and then dry them out. The bacteria go completely dormant. So now instead of hauling a heavy liquid, you have a lightweight shelf-stable seed.
That you can just toss onto a dune in the middle of nowhere without heavy machinery.
Exactly, and it just sits there.
Just waiting. It's basically an automated biological agent. As soon as it rains, the water dissolves the pellet. The bacteria wake up and they immediately migrate to the surface to photosynthesize and bind the sand.
It's amazing to see how much faster things move when you have smart agents doing the heavy lifting for you.
Which actually feels like a perfect segue to our sponsor, Embersilk. Because if you want to accelerate your own workflows, you really need to check them out.
Absolutely.
Whether you need help with AI training or automation or integration or even custom software development, they are the experts. They help uncover where agents can make the absolute most impact for your business or your personal life. Check out embersilk.com for all your AI needs.
That is embersilk.com. Highly recommend them.
So getting back to the desert, we established that nature takes decades to build this crust. What kind of acceleration are we actually seeing with these soil seeds?
The data is honestly staggering. Natural crust takes about 15 years to even start forming properly. But with this new method, they are seeing a stable, erosion-resistant crust in just 10 to 16 months.
That cuts a century-long sand fixation effort down to a 3-year achievable target.
Yes, and they often pair this with straw checkerboards.
Oh, those grid patterns of straw pushed into the sand.
Exactly. That reduces the wind speed at the surface, which protects the crust while it grows. And once that protosoil is there, it creates a nutrient-rich foundation. Then vascular plants like shrubs and grasses can finally take root.
And the scale of this isn't small either. They're integrating this into the Three North Shelterbelt program right now.
The Great Green Wall. Yes, it is massive. They plan to rehabilitate 5,000 to 6,000 hectares in just the next 5 years.
It's essentially biological geoengineering, transforming loose, shifting sand into a stable surface capable of supporting life. It offers such a scalable and optimistic solution to desertification.
It really highlights human ingenuity. We are literally figuring out how to heal the Earth using its own microscopic tools.
It is incredibly inspiring. So here's the thought I want to leave you with today. If we can engineer a living skin for a desert here on Earth, pack it into a dry pellet, and wake it up with just a little rain, what does that imply for rehabilitating other barren environments?
Or even other planets. If we can make life take hold in the Taklamakan, then Mars really doesn't seem so far out of reach.
If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.